Welcome to this video. In this video, we will be collecting data from the WorldBank API and doing some visualizations. We are interested in the GDP and education data in the USA. So this function getData is basically a function that sends a request, an API request, and then parses the response and basically returns the country, the year, and the value of the indicator. It takes two parameters, country indicator, and it will return a data frame. Next, we use this function to get GDP data of the USA as well as education data in the USA. Let's take a look at some of these questions. How do GDP and education change over time? Is there a relationship between both? And do the results apply in other countries? What I'm going to do here, I'm going to combine data from these, the GDP and education data in one data frame. Because right now we have two data frames. Let's take a look at these two data frames. That's the GDP per capita data frame, and this is the education data frame. And we notice here that we can join these two data frames. We have the same country, and we can combine both years, same year's observation for both years. What I'm going to do here, I'm going to use the function merge, pd.merge, to merge the two data frames. So I'm going to merge the GDP data frame with the education data frame, and I'm going to specify the join to be outer. The reason is that I'm not sure if the same year it exists in both data frames. So to be safe, I'm going to use outer join in this case. My specification here was incomplete because I wanted to join on country and year. What happened here is that Panda joined on country, year, and value, and obviously this is not what I want to do. So I'm going to specify left on country and year, and I'm going to specify right on to be country and year as well. Now I have value X and value Y. So value X is basically the GDP, and value Y is the education. What I'm going to do here, I'm going to save this in a data frame, and then I'm going to call the columns of the data frame country, year, GDP, and education. I'm going now to paste the country, year, value X, and value Y. Obviously value X is the GDP. This one should be GDP per capita, so I'm going to do GDP. And value Y, education. That's the percentage of population who have completed at least post-secondary education. So I'm going to call this one education in this case. Plus I'm just going to use uppercase for all. Okay, so that's my data frame. Now let's start doing some visualization. Now the question here, how did GDP and education change over time? So let's take a look at each one independently. So let's start with a GDP. I'm going to create an Altair chart from my data frame, and I'm going to use a line encoding, so basically create a timeline. X will be year, and then next my Y would be GDP. I forgot the encode function, so I need to call function markLine to specify the graphical mark, and then call the encode function to specify the encoding channels here. And we can see that the GDP has been increasing over time. Now it seems that we have missing data here, and this is because we combined the two data frame using an outer join. Anyhow, it looks like data from 1990 onwards shows an increasing GDP per capita over time. Let's call this one chart 1. I'm going to save it because I want to combine it with a chart about the education. Next, I'm going to create a similar chart. This one will be chart 2. I'm going to use the same line graphical mark, same encoding, but I'm going to put education on the y-axis. And here we see that we have some data points here, but we have some gaps, so the data itself is incomplete compared to the GDP per capita. So the percentage of educated people has increased over time, although we have a gap in terms of data collection here. Next, I'm going to put the two charts side by side. So I'm going to use the vertical operator here to put chart 1 and chart 2 side by side. And you can see here that I have the two trends plotted together side by side. The question here is asking us of whether there is a relationship between education and GDP. This is probably hard to tease out by comparing two line charts. We see that the relationship over time is increasing. So we probably can do a scatter chart to relate the two quantities, education and GDP. So what I'm going to do here, I'm going to create another chart, and I'm going to use mark point, the graphical mark, and I'm going to encode my x's and my y to be the GDP and education. So it seems though, except for one outlier here, the trend is kind of linear. There is a linear relationship between the two quantities. And indeed, if I do a line encoding here, I'm going to get a line. I'm curious though to see what this outlier refers to. So what I'm going to do here, I'm going to use another encoding channel, let's say tooltip, to be year. You know the country is the USA, right? So I'm interested in knowing the year in which this outlier happened here. And this is 1994. I'm not so sure why that happened. It could be an outlier, it could be an inaccuracy in the data collection, or maybe there is something that explains why in 1994 the GDP was so low, but percentage of educated citizens was higher than other years. It's interesting. I don't find any plausible explanation to this outlier here. Next question is asking us to probe this relationship or this result for other countries. So we can repeat this process for other countries. What's nice about using Altair is that the chart that we're creating is basically an object. So we can encapsulate everything we have done so far in a function. Let's do that. Let's create a function called visualize. And this function will take a country name. So we're going to basically repeat these steps for any country that we get. I'm going to grab the data for both education and GDP for the country. Of course, instead of the USA, I'm going to call this one country GDP. And I'm going to do the same thing for education. Country education, and then I'm going to repeat the same process here. I'm going to combine the two data frames in a collective data frame. I just want to be sure not to kind of self-inflict a copy and paste error in this case. So make sure I'm operating on the country data frames here. Next, I'm going to create my chart. I can use the mark point, or I can use mark line. So that's the chart object. Now this is a function, so the function needs to return that object. Okay, so basically I took the steps that I have kind of pursued and validated above and put them in a function. So we can try this, and I'm going to test it on the USA first, just to make sure it's working and it's kind of giving us what we are expecting. So that's the same chart. And I'm going to do Canada here. Now this is going to grab brand new data from the World Bank and is going to create a visualization for Canada here. It looks like I got something similar to the previous chart, so I'm a bit suspicious that something wrong is going on here. So let's see. I'm going to change this one to data just to make sure. Okay, so here is the mistake. The mistake is that I pasted this without changing USA to country. It's always important to test functions on input-output that we know are correct before plugging these functions in production. So that's the chart for Canada, and we don't have many data points in the case of Canada here. And we can use, for instance, mark line if we want to have a line, and the line will interpolate, basically connect the dots. And we have many gaps here, so that's probably why a line doesn't show up. So I'm going to default to mark point. Let's try Mexico, for instance. That's the chart for Mexico. And obviously those are charts, Altair charts, so we can combine them. So we can do visualize USA side by side, visualize, or maybe one underneath the other, visualize Canada in this case, and visualize Mexico. And what we get here, 3 charts, 1 chart per each one of the country. And underneath the hood, this data was fetched from the internet, from the World Bank. We did all of the transformation needed, and we created a figure, one figure. This figure can be exported if we wish, or it can be saved as an interactive figure as well. So this concludes this exercise. And again, it shows the power of the grammar of graphics, coupled with everything we learned about in data transformation and data integration, reading data from the internet.